Welcome to Algebra, Chapter 1, Section 9, Patterns, Equations, and Graphs. Here's a definition to add to your notes. It is solution. A solution of an equation with two variables, x and y, is any ordered pair xy that makes the equation true. As an example, we have the coordinates 5, 20, where x is equal to 5 and y is equal to 20. If I put that in the equation y equals 4x, we see that 20 equals 4 times 5. And this proves that the coordinate 5, 20 is a solution to the equation y equals 4x. Here's one for us to try. Together, we are going to work on y equals 2x plus 1 and determine which one of these, a, b, c, or d, is a solution to this equation. To do that, we're going to take each coordinate point and put in the first value for x and the second value for y until we determine which one is the solution. So if I have y equals 2x plus 1, I'm going to say which one of these, when I put in the values in the correct spot, is a solution. For the first one, put 0 in for 2 and 1 in for y. So you have 1 equals 0 plus 1. 1 equals 1. That is true. That is a solution. Now let's look at why the others are not solutions. Let's put in y equals 2x plus 1. If we put in 4 equals 2 times 2 plus 1. Remember, this is my x and this is my y, so they fill those holes. Does 4 equal 4 plus 1? No, it doesn't. So that is not a solution. As you can see, when we put in 10 for x and 21 for y, we have 21 equals 20 plus 1. Is that a solution? Yes, it is. So we now have two solutions. For the last one, we'll put a negative 2 in for x and a negative 5 in for y. And as you can see, negative 5 equals negative 4 plus 1. That is not true. So D is not a solution. So our solutions is point A, 0, 1, and point C, 10, 21. Both of those are solutions to our equation. This is a try this for you to try. Go ahead and fill out the chart in your notes. You don't have to write everything out, but focus on the important parts and show it. You can represent the same relationship between two variables in several different ways. We've seen them represented as a table, an equation, and a graph. Problem 2. This does not have to be written into your notes, just pay attention as we go through it. Will runs 6 laps before Megan joins him at the track. They then run together at the same pace. How can you represent the relationship between the number of laps Will runs and the number of laps Megan runs in different ways? We will use a table, an equation, and then on the next slide, a graph. So first the table. Megan starts out, she has ran 0 laps, Will has run 6. When Megan runs 1, Will has done 7. 2 for Megan means 8 for Will. 3 for Megan means 9 for Will. 4 for Megan, 10. 5 and 11. 6 and 12. 7 and 13. So which relationship represents this table? Which one did you guess? Will runs 6 more laps than Megan. So when we let x equal the number of laps that Megan runs, and we're going to let y equal the number of laps for Will. In this relationship, will always run more laps than Megan. So y will always be greater than x. Now to write an equation to represent this relationship, we will say that y is going to always equal, well, Will runs will always equal Megan's run plus 6. So as you can see, we have done it in a table and we have done it in an equation. The third way is to use a graph. The ordered pair that corresponds to Megan arriving at the track is 0, 6. We can use the table to write 3 more ordered pairs. Now you might be able to flip back to your table. I'm just going to write them in here. We had 2, 8, we had 4, 10, and we had 6, 12. Now let's go ahead and graph those ordered pairs. 0, 6. And I can't really graph these until I actually put in my labels. So let's put laps for Will down here. And let's put in laps for Megan here. So when Will was at 6 laps, Megan was at 0. When Will was at 8 laps, Megan was at 2. When Will was at 10 laps, Megan was at 4. And then we have 12 and 6. So as you can see, we have a linear graph here. A second concept and definition to add to your notes is inductive reasoning. Inductive reasoning is a process of reaching a conclusion based on observed pattern. It's used to predict values, to make predictions. In this problem, I have shown you a pattern, and we're going to extend that pattern. So take a moment and count the number of tiles, how many black, how many white, so we can fill in the table. Again, your table doesn't need to be as extensive as this, just a couple straight. As you can see, I went ahead and filled in the figure. When there are 4 black tiles, we have 9 tiles total. When there are 8 black tiles, there's 18 tiles total. And when there is 12 black tiles, as in this case right here, there are 27 total tiles. Now we're going to use this to predict a future value. And what we want to know is when a figure has 24 black tiles, how many total tiles will there have? Go ahead and pause this video, take a minute and see if you can figure out both the multiple choice question and the answer to when there's 24 black tiles. Well, did you see the pattern? Every time this increases by 4, the total number of tiles increases by 9. So a figure with 24 black tiles will have how many total tiles? A couple ways you can look at this. If you continue the pattern, you'll know that the next set after 12 will be 16, and 16 will have 36 total tiles. And then you'll have 20, and 20 will have 45 total tiles. And then 24 will have 54 total tiles. So our answer would be 54. If you chose not to do that, you could also look for combinations. For example, you know that 24 is 2 times 12. Well, looking at your pattern, you could have looked at this. Double 12, what do you get? Double 27, what do you get? And that'd be another way of looking at it. So in your notes should be 2 definitions plus some other random notes. And I want you to go ahead and do this, try this. There are 3 try this problem. And then make sure that you understand what a solution of an equation is, what inductive reasoning is, and give me an idea if you feel comfortable with this information or not.